A train travels between two cities A and B. The train starts from rest at A and accelerates at a constant rate for t seconds until it reaches a speed of 25 meters per second. Travels with the constant speed, constant acceleration, accelerates at a constant rate. Straight line will be there. Or t second was taken, and the speed gained within these t seconds was 25 meters per second. It then travels at a constant speed before decelerating at a constant rate, coming to the rest at B. The magnitude of the train's deceleration is twice the magnitude of acceleration. The total time taken for the journey is 180 seconds. Sketch the velocity time graph for the train's journey from A to B. So definitely from first part it accelerates with the constant speed, so there will be a straight line. 25 meters per second in t seconds. Then it moves with a constant speed. That will be a horizontal line. And then decelerates at a twice deceleration, twice rate as compared to the acceleration. So it means this time, this portion of the time will be t 0.5 t, you can say, half t, because the time taken as the rate of deceleration is twice, so the time taken will be half. That is the first part. The second part is find an expression in terms of t for the length of time for which the train is traveling with the constant speed. So actually we are asked to find this part, this time, whereas we are given that it takes 180 seconds totally. 180 minus t minus 0.5 t. So that will be 180 minus 1.5 t. So that is the expression for the length of time for which the train is traveling with the constant speed. Here in the diagram is this duration. The distance from A to B is 3300 meters. Find how far the train travels while it is decelerating. Area of the trapezium, half. Sum of parallel lines, one is 180 plus other we have just calculated, and height is 25, is equal to 3300. So that gives us 360 minus 1.5 t is equal to 3300 multiplied by 2 divided by 25. 3300 multiplied by 2 and then divided by 25 gives us 264. 264 minus 360 is equal to minus 1.5 t. So 264 minus 360 will give us negative 96, and t will be minus 1.5. This will be divided by minus 1.5, and that will give us 64. And we are asked to find how far the train travels while it is decelerating. In other words, we need to find this area of this triangle, because this is the distance in speed time graph or velocity time graph is the area under the graph. So area under the graph here is the triangle, which will be half, and the base is 32. Why? Because this is 0.2, 0.5 t, or you can say half t, 64, half of 64, and then 25. So the distance covered is 16 times 25, which is 400, which is 400 meters. Question number 7. Two particles A and B of masses mkg and 4 kg respectively, they are connected by a light inextensible string that passes over a fixed smooth pulley. Particle A is on a rough fixed slope, which is an angle of 30 to the horizontal ground. Particle B hangs vertically below the pulley and is 0.5 meter above the ground. See the diagram. The coefficient of friction between the slope and the particle A is 0.2 in case where the system is in equilibrium. So the first thing, the system is in equilibrium with the particle A on the point of moving directly up the slope. So limiting friction will be there. Show that M is distant correct to 3 significant figures. So the first thing what we do is let's resolve the forces. There will be mg Newton. The perpendicular will be mg cos 30, and this will be mg sin 30. The reaction force will be there, and since the particle A is just to move towards, means up the slope, on the point of moving directly up the slope, so the force of friction will be backward. Tension T will be in this direction. In this case there will be T, and in this case this will be 4 kg 40 Newton. So since the particle is in equilibrium, so the forces A has T minus mg sin 30 plus mu r, which is mg cos 30, and that will be equal to, this is like that, or you can, that will be equal to T, because the body is in equilibrium, that will be equal to T minus 40. So they will be cancelled, minus minus will be cancelled. In other words, mg sin 30 is, that will be 5m, because sin 30 is 1 over 2, g is 10, 10 over 2, 5m, plus now this is 0.2, m is 0. Mu is 0.2 multiplied by m will remain m, g is 10 multiplied by cos 30, that is 1.732. So 1.732 m, that is equal to 40. This becomes 6.732 m is equal to 40. So that gives us m is equal to 40 divided by 6.732, that is 5.9417. 5.9417, which is equal to 5.94, correct to the three significant figures hence shown. The second part of the question is in the case where m is 3, the system is released from rest with the string torque. Find the total distance traveled by A before coming to instantaneous rest. You may assume that A does not reach the pulley. The first thing we need is to have the diagram. Let's have the diagram. चलें जी, ये diagram है, मैंने दोबारा इसको copy और paste कर दिया. So what you can see here is, let's see कि अब m जो है, it is given that m is equal to 3 kilograms. m is the value of m is 3. और उसके बाद ये कहा कि अब ये देखें the forces on and it's now released, so it will start moving towards A will start moving towards B and B will start moving towards the ground. तो यहाँ पे तो हमारे पास है जनाब 40 न्यूटन नीचे और ऊपर हमारे पास the tension will be in this direction. Same tension इधर होगी in the string और यहाँ पे आपके पास हो जाएगा mg sin 30. तो mg जो है हमारे पास 30 mg, because m is 3, g is 10, 30 sin 30. वैसे sin 30 is half, तो हम इसको 15 भी लिख सकते हैं. तो 15 न्यूटन फोर्स will be along, means parallel to the surface, और जो ये perpendicular होगी वो हमारे पास होगी mg, again mg cos 30, which will be 30 cos 30, which is 30 times cos 30, which is 25.98. 25, 30 times cos 30, 25.98. 981, because 07 है तो ठीक है. और that will be basically the reaction. और हमें म्यू की वैल्यू भी उसने दे दी थी in the first part, that was 0.2. ये हो गया. This is the forces has been resolved. Let's see, consider the part of the particle B. So it's as it's moving downward, तो हमारे पास आ गया 40 backward, forward force minus backward is equal to ma. This is the force is equal to ma for second law, Newton's second law of motion लगा लेंगे ना. That is equal to ma, so that will be 4a. This is the first equation. Now looking at A, since A is moving towards B upward, so it will be T minus 30 sin 30, which is 15, minus mu r 0.2 times r हमने calculate किया था 25.98, and that is equal to 3a. This is the second. इसको और simplify कर लेते हैं हम, तो ये आपके पास हो जाएगा t माइनस, अब ये हो गया आपके पास 25.98 multiplied by 0.2, that gives us 5.196, इसमें मैं ऐड कर रहा हूँ 15 वाई बिकॉज बोथ हैव द सेम साइंस माइनस नेगेटिव नेगेटिव, तो ये टोटल हमारे पास बन जाते हैं 20.196. 20.196 is equal to 3a. This is the second equation we have got. Now, by adding 1 and 2, 1 आपके पास थी ये वाली इक्वेशन और 2 है हमारे पास ये वाली इक्वेशन। तो जब हम इन दोनों को ऐड करेंगे t will be cancelled, we will have 40 minus 20.196 is equal to 7a. So 40 minus 20.196 is equal to 19.8031. So that is 19.8 is equal to 7a. So here we get a is equal to 19.8 divided by 7, which is 2.829. So we can say 2.83 meter per second square. So we have got acceleration. So this is 2.83. Now the next thing is this. In this case, there will be two parts of the journeys. First part, the B reaches the ground, and obviously A has moved 0.5 meters ahead. String will become slack. And the second segment, A will come to instantaneous rest later. First part, distance covered is 0.5. Actually, we need the velocity at that time. And S is 0.5. And what else we have? We have calculated A, which is 2.83 meter per second square. U is 0 meter per second. And actually we want to find what would be the velocity at that time. Velocity will be 2as v square minus u square, which is v square is equal to 2 times 2.83 and s is 0.5. So that is v square is 2.83. The square root of 2.83 is 1.68. So we will be 1.68226. So it will be 1.68 correct to three significant figures. So once the B has arrived at the ground, and say this is here. Now here the velocity we have just calculated is now 1.68, which will become u here. 1.68. It will keep moving ahead. So let's see what would be the condition there. So that will be t minus the same thing I'm taking, t minus 30 sine 30, which is 15, minus mu r 0.2 times 25.98. That is equal to 3a. T as the string that has become slack. So no t is there. So t will be 0. So we will left with this value, and this value the total was 20 point. It was yes 20 point minus 20.196 is equal to 3a 20.196 divided by 3, that gives us minus 6.76.732. That will be the acceleration when the string will become slack. Actually, we need the distance covered in the second segment. So we know, as I have mentioned, u is 1.68. Here u is 1.68 meter per second. V is 0. A is minus 6.732. We will apply the formula. 2as is equal to v square minus u square. So 2 times A is minus 6.732. S we are going to find is equal to v square, which is 0 square minus 1.68 square. So that will become S is equal to minus 1.68 square over minus 2 times 6.732. Negative negative will be cancelled. 0.209, 0.2096, 0.210. So the total distance covered will be, because there are two parts, one part is the first part is it has moved 0.5 meters, and now when it becomes at this position in the instantaneous rest, further 0.210. So the total distance will be 0.5 plus 0.21, which is 0.71 meters. 0.71 meters. That's all.